Hello, everybody. My name is Jean-Baptiste and I am a student of International Development of the High School of Global and Public Affairs in Madrid. I am doing this video in the context of my master thesis, where I'm exploring the impact of crowdsourcing and machine learning in natural disaster management. And this is kind of a tutorial for building image recognition applications for rapid infrastructure damage assessments. So, as you can see, I'm in the middle of a disaster zone and it looks pretty bad. In these situations, governments, humanitarian organizations, and local networks of responders need to act fast and bring help to the people in need. To do that, they need access to accurate and useful information so that they can make evidence-based decisions, and they need to do it fast. It would be extremely helpful, for example, to find a way to conduct a rapid and precise assessment of the infrastructure that has been damaged. Which roads are still usable? Where are the bridges that resisted the earthquake? What gas stations are still operational? From right here, by myself, it would be pretty hard to answer all those questions. So I have decided to train a machine learning algorithm in the task of classifying satellite imagery of areas hit by the disaster. This will help me automate the classification of thousands of images that I could never dream of analyzing all by myself or even with a team of analysts. It would just take too much time and become useless. So the first thing I need to do is to find a dataset of satellite images that has labels that will tell the algorithm which images contain damaged infrastructure and which don't, so that it can learn the differences. This step is called the training phase, and in order to have an algorithm that makes accurate predictions, I need a large dataset with quality images and quality labels. Finding this type of data is challenging, and that is why it could be useful to create it and train algorithms during the preparedness phase of disaster management before natural events happen, in order to have pre-trained models that can learn faster when a new disaster happens. All right, so luckily there are multiple open data initiatives that have emerged over time and that have this mission of creating these large data sets full of images that have been labeled so that people can actually create generalizable machine learning models that can be used in different disasters when they arrive. So one of these initiatives that I'm going to show you right now and that I used for this demonstration is the XView2 challenge. As you can see, it contains images from 6 disaster types, which is very good because it will make the model more accurate. It covers 45,000 square kilometers. It has images from pre and post-disaster situations, and it labels those images using this joint damage scale with 4 layers. So no damage, minor damage, major damage, and destroyed. Okay, so now that I have the data, I need to train my model with all these labeled images. But wait, there's a problem. I don't even know how to code, so how can I do this? And here comes Giotto, which is it's a platform, it's a commercial platform built in Switzerland by a team of brilliant people. And these crazy guys, they basically took up the challenge of building a platform that allows people like me with no knowledge of coding, I mean just basic, who do not know how to build machine learning models to create machine learning based applications. I'm going to sign up. It's free, and they also give you free credits in the beginning if you want to test the platform. So I'm going to guide you on how I use Giotto to actually build my image recognition infrastructure damage assessment application. So here, I just create a new project. I'm going to call it infra damage, create project. So here I choose the task that I want to do. I need to do image recognition. Do I need to do segmentation or classification? I need to classify images that contain damaged infrastructure according to the scale that was defined by the XView labels, the 4 grades of damage. So here I'm going to upload the dataset that I already uploaded to the Giotto cloud. It's this one. And here it's important to note that the entire dataset that I downloaded contains 8,000 images, 8,000 high resolution images, which is a lot. And I've decided that I will not train the model on all those images because it would take too much time. And I need to be fast. Remember, I'm in an emergency situation. I need to make compromises. So I decided that my model might be slightly less accurate with less training data, but I will have it sooner. So I isolated 3,000 images only with pictures from every disaster. And in order to test my model, what Giotto will do is that it will perform cross-validation. This means that from those 3,000 training images, it will take 2,400 images to train the model, and it will keep 600 images unseen by the model that it will show to the end to actually test the accuracy of the model. So here, as you can see, it shows some pictures with labels. This one is destroyed, etc., etc. So the pre-processing step. Here, what Giotto will do is called data augmentation. It means that it will modify some parameters of the pictures, such as brightness, contrast, tilt. It will flip them horizontally and vertically in order to create more pictures that will enable the algorithm to learn better how to distinguish images. So I selected all the data augmentation steps that Giotto offers. This is just a summary, and it will show you some of the new pictures it has created. Giotto, where are the pictures? Here they are. You see the modified brightness, random crop, etc., etc. Then, I do not need feature engineering for this type of task. Here, I need to choose the model, and here I will make another compromise because there are some models, such as the ResNet 152, which are extremely powerful, but they need a lot of time for training. So I will choose a balance. I will choose the ResNet 50, which is good and will not need that much time for training, because remember that I need this model as soon as possible. It's an emergency situation. Once I reach this step, the only hyperparameters that is interesting is actually the number of epochs. An epoch is the process of the algorithm running through all the images back and forth, okay? So the more epochs I have, the more the algorithm is supposed to learn. So I will choose 100 epochs. Great. And now I just need to click here to train the model. As you can see, it gives me information on the time of training, 1 hour, and the price. I will not click training because I already trained the model for this demonstration. So I am going to go straight to the results of the training and show you what happened. Great, so now 1 hour has passed since we launched the training of our model, and we're going to go back to Giotto and check the results. So as you can see, Giotto offers this visualization page that allows you to understand the performance of your model. So what's interesting is that we used the ResNet 50 with 100 epochs, and we achieved an accuracy of 71%, which is pretty good. So here, as I said before, the validation split of the cross-validation was 20%. So this means that Giotto isolated 2,400 images for the training and tested the model on 600 images. So Giotto also offers the possibility to download a PDF, but it also offers something else which is far more interesting, which is the possibility of creating a web app. And basically, if you have a web app, it means that you have your model that is there in the web app. And then when you have a new disaster that happens, you quickly collect unlabeled data from satellite imagery, and you're going to use your generalizable model that you built with Giotto and train it on this new data using transfer learning in order to have an easily deployable model. All right, so now I'm going to show you how we can use this web app to actually test the model to classify some new images that are not labeled that we have collected from another disaster. So here I go to the web app that I created with Giotto. As you can see, Cloud, Giotto, Disaster Management. And I have just uploaded some unlabeled images from the XView dataset. As you can see, there is no label. The model has not run. I'm going to run the classification and let's see what happens. So here it detects a major damage. Let me go back. Here there is no damage, major damage, minor damage. As you can see, Giotto is classifying the pictures according to the scale that we have defined with XView. So now we're reaching the end of this demonstration and this little tutorial, and I have my generalizable model, which I built without having to write a single line of code. And this is the most interesting part. And I say generalizable because I trained it on images from multiple disasters. And this means that it should perform pretty well when tested on a new disaster, or at least it should perform better than a model that has been trained with images only from wildfires, for example, or flooded areas. Anyway, there are several solutions to improve the accuracy of this model, which is 71%, which is already not bad with a small training data set that took only 1 hour of training. And one of these solutions to improve the accuracy is active learning, which I explore in my thesis, and which integrates a human component in the training of the algorithm, helping the model label unlabeled data more accurately. And this is a feature that will be included in the next release of Giotto. And actually, in the next release of Giotto, there will also be the possibility to build natural language processing models that analyze text. And I will definitely test it on crisis data generated on Twitter and other social networks. When that happens, I will have a model to conduct assessments from the sky using satellite imagery, and another model to take the pulse of the disaster on the ground through the messages that affected populations post on social networks. So what other things could be done with this? Let's think a bit forward. Let's imagine that during the preparedness phase of a disaster, governments equip local networks of responders with drones and licenses to fly those drones. So as soon as disaster hit, these responders could fly their drones, taking thousands of very high resolution pictures without having to wait for satellite imagery. Then these responders would use a crowdsourcing platform to quickly label the images collected by the drones in order to create a good training dataset for a model. With this training dataset, they could use Giotto, for example, to build a model that automatically identifies features of interest from those images. The only problem here, of course, is that Giotto runs its calculations on the cloud. And this can be a problem during natural disasters that damage infrastructure and cause power outages. So to the team from Giotto, you should definitely think about working on an offline version of the platform that people could use, for example, on gaming computers that have a lot of processing power and can run those calculations offline. When that happens, because it's already happening, local people on the ground, victims of disasters, will need a drone and a gaming computer with the offline Giotto app to use these kind of technologies and do things that normally only very rich governments and well-founded humanitarian agencies could do. So I hope you enjoyed this little demonstration and tutorial, and I hope that I transmitted the message that these technologies are actually available to almost anyone who wishes to use them and implement them. Thanks a lot for the attention.